Where did the rocks go? As you know, our landscape is continually changing. Originally, this earth was just one great big ball of molten rock, and we know that originally it would have just solidified on the outside and had a lovely gooey interior like we still have down in the middle of the earth today. However, the rocks that originally surrounded our earth have been covered by a variety of living organisms, and they're continually moving around and moving back into the inside of the earth and being pushed up out of the earth into mountains, and they're continually changing. So the big question is, how is the earth changing and what stories are hidden in that earth? And it all starts with, where did the rocks go? Okay, when you come to think about rocks changing, you have to think about the ways they're changing and what drives these changes. Okay, a few things, let's have a look. Okay, rocks change physically and they change chemically. Physical means you haven't made a new substance, but you change its state, so going from liquid to solid to gas, or its shape, or its position. Chemical changes is where we have a new substance being formed, and this is through a chemical reaction. So what was there before is gone, and it's turned into something new. What drives these chemical reactions? Well, there's two things. There is plate tectonics and there is weathering. Plate tectonics is what we see when we have the plates, the crust plates of rock that are on the earth. Okay, the earth is like this, and it's divided up into many different pieces, and each of these pieces is moving in different directions depending on what's beneath them. And those crusts hit into each other, push apart, and because they're moving around, they can cause either a physical or a chemical change. Weathering is what happens because of living and non-living things on the surface of the earth. We have living things breaking down rocks, and we have non-living things like wind and rain that also break down our rocks and change them. And over time, the rocks actually mix with the dead organic matter, that's us, the dead living things, and as we break down and the rocks break down, the two join together to make soil, which again goes back into supporting living things on Earth. Now here's some pictures of plate movements. We have different movements. Divergent means that they pull apart, and as they do, the lava from below, or magma, comes up, and as it gets released, we call it lava, and it makes new land where there was a hole before. Convergent means that they're moving together, and when they converge, two things can happen. Either both push and both win, and they end up pushing up into mountains, or one loses and gets pushed down below into what we call the mantle, where it gets reliquefied, melts, and one gets pushed up because it wins and it turns into mountains. And we see this along a lot of our continents where they meet the ocean. Lastly, we have transform plate movements. This is where one plate is moving in the opposite direction to another plate, and they tend to grab each other like this. Think about it. Rock is not smooth. They grab each other and they're pulling against each other, trying to move against each other, but they can't because they're stuck, and then eventually they'll rip through and apart, and that's how we have earthquakes. We see that happening an awful lot in America. Now, this was, whoops, there's supposed to be a movie there, but you can watch that separate to this recording. Okay, tectonic movement, heat and pressure on rocks. What you need to know is that when we have, so heat and pressure cause changes, and they can be both physical and chemical. So you can literally have something heating up and it will melt or heating up or cooling down, it will melt or solidify rock, but it's still the same type of rock. So that's what we call a change in state. It's a physical change. But if you heat something high enough or push it hard enough, you can actually force the atoms to rearrange their bonds and rearrange how they're sitting, and that will cause something new to be made, a chemical reaction. So this is where we cook rock, and it actually changes the properties in this rock, and you're going to learn about that in metamorphic rock, because if you cook rock, you literally make something new and you change its properties, you make it stronger. So when you cause a chemical change, you often make rocks stronger. Okay, weathering is another way of changing rock, and we have physical and chemical weathering. Okay, we can have temperature causing changes to rock. So when things get hot and cold, they expand and they contract, get bigger and smaller. Now, if this is happening to rock, well, they really don't like to expand and contract. They tend to crack when that happens. And as soon as they crack, other things can get in, like water and ice and salt and salt water and living things as well. And as soon as these guys get into those cracks, they break the rock again apart even further. So water gets into rocks and it can dissolve it. Or if water freezes in the cracks, it can expand and crack it further. Salt can grow salts inside the cracks and the crystals expand and crack the rocks further. Wind, well, if you've ever stuck your head out of a car when it's driving really, really fast, you know that abrasive particles in the air will hit you and sand your skin. Well, this happens to rocks too. Wind can wear it down. Also living things, we tend to wear things down when we walk and move and crack and break and hit them all the time. So that's physical or mechanical weathering of rocks. Chemical weathering is where we make something new, and that's important to remember. So there's different ways you can make something new, either water or acid rain, which is water with acid in it, and gases. They can all react with the rocks, and you know that they're reacting if the rocks change colour or change in strength, so you can actually see them breaking down and falling apart. And when you see all of that happening, you know that the rocks are not just breaking down physically, but they're actually making something new. It's called chemical weathering. Living things too can cause chemical weathering. We tend to release an awful lot of acid, usually in the form of pee. And when we do that, that breaks down the rocks and releases the nutrients that are in there and helps to make soil, which living things like as well. Here's a picture of how water can turn into ice and crack rock further. And lastly, what happens to all of that broken down rock? Well, it doesn't stay put, does it? It moves. So when rock moves, we call it erosion. And water, wind and ice tend to be the main agents of erosion and moving rock, although humans are pretty good at moving rock around too. We tend to like to pile it up in trucks and move it away to where we want it. Here's a picture of natural erosion. You can actually see here a windstorm blowing pieces of rock and soil across the area and literally moving it around. Here's some coastal erosion caused by water. This rock and the soil that it's embedded in and being washed into the water there. And here is ice. This is actually a frozen river. We call it a glacier. And glaciers are, although they don't look like they're moving, they are. And this river is slowly moving down this way. That's why you see these lines in it like that. And as ice moves, anyone who's ever tried to move along ice knows it's quite rough. It gouges out the landscape. Here's what's left over here, a great big gouge through the landscape. Okay, when the broken down rock is moved away, where does it go? Well, it has to be deposited somewhere else. And after a while, so many layers get layered on top of each other that it starts compressing each other and pressing down into the earth. So the last part of this cycle that you're going to learn about is sedimentation and compaction. Sedimentation is where things are deposited somewhere else, and compaction is where layers build up and up and up and up, and they start pressing down on each other, and eventually you get those layers in a smaller form. That's compaction. And that's how rocks tend to form from sediments, and you'll find that out a little bit later when we learn about sedimentary rock. Here's a few more pictures that we're just going to add in here. This is rock that's been layered by, believe it or not, a sandstorm. This was formed in a desert, and you see this, what we call cross-beading here, in rocks that are formed in deserts from sandstorms and sand layering. Here's another picture of layering. This is the Grand Canyon. Look at all of these rock layers laid down over time. Now, as you can imagine, the rock down here is under heaps and heaps of pressure. It's screaming out, okay? Because it's under heaps of pressure, pushing it down and making it tougher as it compacts down. Now, that's pretty much how rocks change in a nutshell. From now, you're going to be learning about all the different types of rocks and exactly how they are made and formed and changed and how they fit into what we call the rock cycle.